In example 5, it says the shadow of a tower standing on the level ground is found to be 40 meters longer when the sun's altitude is 30 degree than when it is 60 degree. We have to find the height of the tower. So let's make a tower first. Say I've made a tower this, and let's make two shadows. Say this is one shadow, and let's say this being the other shadow. So I can use colors here to indicate properly. This is the first shadow I've taken. Say this being the first shadow, and this being the second shadow. Right, from the figure, these are the two shadows formed. And then you know that in this case, we have to draw an horizontal as it involves angle of depression. So I've drawn this horizontal, and then I'm joining this two with the two different points that we obtained. That is, one is this, and the second one is this. This is the second one. The angle of depression to the nearer point, and then angle of depression to the further point. Now let's say AB being the height of the tower, and say P is the first point, say L being the second point. As you can see, the angle of depression, this is smaller, so this is say 30 degree, and this being the bigger angle, so it has to be 60 degree. By alternate interior angles, we can write this as 30 degree and this as 60 degree. We have to find the height of the tower, but before that, can you see that it says that the one shadow is longer than the other. Like this is the longer shadow and this is the shorter shadow. So the longer shadow is 40 meter more than the shorter. That means we can see that their difference, which is the difference is 40. That means we say PL is 40 here. PL is 40. So let's write down this as 40. This is missing, so we can take it as X, and the height of the tower we have taken as H. That's what we have to calculate. This is what we have to get. So we can start with a right angle triangle. Let's say I took the first right angle triangle. In a right triangle, this is a right angle triangle. We have ABP. We'll apply tan as it gives the relation between perpendicular and base. We can also apply cot. So tan 60 is equal to perpendicular. Perpendicular is AB and base is BP. Tan 60 whose value is root 3. So I replace tan 60 with root 3. AB, which is, we have taken H in this case, and BP as X. By cross multiplication, we get H is equal to root 3 times of X. This is the first relation we got. Now we will take the next triangle. The other triangle here, the right angle triangle, has to be in a right triangle. The bigger one, which is ABL here, we'll apply tan 30, and that is equal to perpendicular, which is AB once again, and the base being the whole base, that is BL. Tan 30 whose value is 1 by root 3 is equal to AB. AB is H and the BL is X plus 40. Same here, we will do cross multiplication. So by cross multiplication, you will get H is equal to X plus 40 over root 3. This is your second equation. Now we can equate these two equations, this and this, to get the value of H. So what we can do here, we can apply equation 1 and 2. So we can write root 3x is equal to x plus 40 over root 3. If you transpose root 3 to the left, it will become 3x. Root 3 into root 3 is 3, right? This, when multiplied with root 3x, will become 3x is equal to x plus 40. And therefore, if you transpose x to the left, so this is 2x is equal to 40. That implies x is equal to 20 meter. So we got the value of x. But what we have to get is the height of the tower. Height of the tower. So we can, in the first equation, we can replace this or substitute x as 20. So height of the tower will be 20 root 3 meter. Right, this is, we can even place the value of root 3 if mentioned in the question, or we may leave the answer here only.